All right, so discussing this situation again, the situation C where you have post collision two billiard balls of the same mass, one moving off, one which was stationary moving off with a higher velocity, and the one which collided into it moving with a slower velocity. So the way we were arguing this, that students yesterday had argued this, is that at the point of collision, what's going to happen is that there is going to be a pair of forces that are acting on them. So the pair of forces will act something like that. This is M1, this is M2. Oh, sorry, I wrote V2 instead of M2. M1, M2. This is at the point of collision, okay, when the collision actually happens. So at that point, we said that, look, the forces are exactly the same on both of these objects, and because the forces are the same and the masses are the same, this situation is not possible, because from this can happen only if one of the masses, that is M2, has lesser has a lesser mass than M1. So if M2 is less than M1, then for the same amount of force by third law, the acceleration on M2 will be greater than the acceleration on M1. Okay. So, but
Yeah.
the question that Ishan asked was that, that is fine, but how do we know that the amount of force required for acting on M1 and the amount of force that is acting on M2 cannot divide the velocities in some ratio by which V2 becomes greater than V1? In other words, why is it that this ball can come and collide into this ball, and this ball move off, and this ball go with a smaller velocity behind? So the second one also follows behind with a smaller velocity. How can you say that the force will make it completely come to a stop? So when I thought about it, it seemed to me that this directly points to something that we have not seen so far. So to answer Ishan's question, yes, it is a possibility. So what he is suggesting can entirely happen. So this is a possibility. Okay. But it's possible only under certain conditions. So what those conditions are? So collisions in general are divided into two categories. Okay. So collisions, two broad categories. One is inelastic collision and another is elastic collision. Okay, so what do these two things mean? Inelastic collisions are simpler to explain, so I'll explain them first. So instead of billiard balls, if you consider, let's say, two clay balls. Okay, so these two are wet clay, and they are heading towards each other. What will happen if two wet clay balls collide with one another?
They'll become one
They,
big lump.
Yeah.
yeah,
Yeah, exactly, right. So when they collide, what is going to happen is that they are going to merge with one another, right? Somehow it became slightly smaller, but let's make it a little bigger. Okay, so they are going to collide into one another and they are going to merge into one another. So if we say this one is M1 and this one is M2, in an inelastic collision, the mass of the object after the collision will become M1 plus M2. Okay,
yeah,
conservation, as long as external forces do not act, conservation laws will still hold over here. All right. So now, is it clear, this one? See, and a variety of different things can happen. You can also have a clay ball being stationary, R situation, okay, and another clay ball coming at it with some velocity, V1. So what will happen after this is these two will merge and they will move off in this direction.
Yeah. Accelerate. Yeah.
Get the point? So
Yeah, because the velocity of the second ball is equal to zero, so it will overtake.
yeah,
And
so M1 plus M2 will move off with some velocity v1 prime. In fact, you don't even need to say v1 prime, you just say v prime because it's one body afterwards. Conservation laws still hold. Okay, so inelastic collisions, wet clay into one another. Now let's look at elastic collisions. So elastic collisions, will somebody try to define now? I have told you inelastic collisions, objects collide and they combine into one another. Would somebody like
So
to
then
know
in elastic, they go in opposite directions maybe.
which situation? Situation 1 or situation 2 you're talking about?
No, sir. In the elastic
Okay, tell me this.
collision. Yeah. Yeah.
What will happen?
So they will move in opposite. Once they collide, they'll move in opposite directions.
Ah, exactly. So what will happen? Hey, were you there in the post-class discussion? Okay,
No.
doesn't matter. Oh, you were in there. Okay, then good guess or good. You have read it before, so that's also good. You have come prepared. So in a perfectly elastic collision, what's going to happen is that two objects that collide into one another with velocities whatever v1 v2, you can initially consider both velocities being equal. So then what will happen is, because in an elastic collision as opposed to an inelastic collision, the two objects cannot merge. Hey, this looks like the beginnings of the cartoon of a guy.
Yeah.
Oh, yeah. Like the mustache is also there.
I can't unsee it.
Also his sort of the point where I left the thing, it looked like his eyes are there, no? So it's like
Yeah.
Oh my god.
or since we haven't understood it yet, maybe we can keep it like that. Okay,
Okay.
so what happens after this is the objects, like billiard balls, cannot merge with one another. So when they clack with one another, they have to bounce back. So there is a complete transfer of momentum that is taking place. The momentum of this one will go to this, moment of this one will go to that. That is just a loose definition. I'll come to that. But yes, what will happen as a result of this collision is that the two objects will collide with one another and move off in opposite directions after the collision. Okay, so this is going to have some velocity v1, no, this is v2, no, so v2 prime, and this will have some other velocity v1 prime. But again, the situation
Yeah.
holds. Law of conservation of momentum will still hold. This is mass m1, this is mass m2, this is mass m1, this is mass m2. So m1 v1 plus m2 v2 will still be equal to m1 v1 prime plus m2 v2 prime. Or in other words, v1 plus v2 will be equal to v1 prime plus v2 prime. So then again, you can apply the conservation laws and get the appropriate result. Of course, when you do it with numbers, this will make more sense. So now what we have to state over here
Do we
is,
do it with numbers once?
numbers, we will do some problem solving. At that time, you will get the point more clearly. But just remember, inelastic collisions, elastic collisions. Okay. So what we
Sir.
are discussing is an idealism. What I have described here is 100% inelastic collision. That means the two objects combine together, and this is a 100% elastic collisions, complete transfer of momentum, no merging of masses can take place. Okay, so you may ask, is it real? In nature, does real elastic and inelastic collisions take place? No, not quite. There is no such thing as a 100% elastic collision and a 100% inelastic collision. Then why talk about them? Well, we talk about them because in science, we try to understand things from idealistic point of view. So if in an ideal elastic collision, this will happen. In an ideal inelastic collision, this will happen. Now in reality, things are never ideal. So it's a combination of elastic and inelastic collisions that are taking place. Then we can use the knowledge we have gained by defining the ideal situation to understand what will happen in our real life situation. Okay, so application is very real. We base our understanding of cosmology on momentum conservation laws. um, Insurance investigators use momentum conservation laws in order to figure out if If there is a car accident, who made the mistake, whether it was the one person who's coming from left to right or the guy who's coming from right.
Really?
Yes, I'll give you the example a little later. Okay, momentum conservation laws work in ballistics, like in forensic sciences. When you have to figure out, you see so many movies or
Oh,
series
oh yeah.
in which you
Yeah,
talk in
sir.
terms of the bullets ballistics. So where it was shot from, which angle it was shot from, where did it enter, where did it come out. All of these things is dependent upon momentum conservation laws. Okay, so the idealistic situation, the ideal situation helps us understand what is going to happen. Then we can use that modeling to understand what will happen in non-ideal real life situations. I hope that point is clear because it's very important. Otherwise, people generally have this feeling things are not, things are spoken in terms of idealism in subjects like physics. There is no real life applications. That's not true. So how does this help us understand this situation? So Ishan, would you like to explain if you figured it out now? Knowing in
No,
elastic,
but I have another question. The
yeah,
inelastic thing will only work if both objects are rigid, right? Are not rigid, right?
are not rigid. Yes, yes. In
So if
fact,
they are rigid, then it will be
yeah, and they're
elastic.
same shape.
Sir,
So
I
if
think in a free
And a lot
situation,
of other things. Addition is also there, but we won't discuss that, the rigidity part of it.
if the M1, the V1 is really, really, really high, then it won't be elastic anymore. It will be inelastic.
No, no. I'm saying that uh, we said a certain situation in which we use third law and our understanding of what will happen by second law to say that this situation cannot happen. So if not Ishan, anybody else, if you can say that, what kind of collision were we talking about in this when we say it is not possible? Was it an elastic collision or an inelastic collision? And when Ishan says, but why can't it so happen that the first one will go faster and the second one will go slower? So in that case, what kind of collision is Ishan talking about? That will make it.
Kind of
So
collision as an inelastic
I
or
think
elastic.
Ishan was talking about, yeah, yeah.
So in elastic collisions, complete transfer of momentum happens. So this situation is not possible because it has to completely transfer.
Exactly.
which means it will come to a
Okay.
stop immediately.
So yeah, to summarize it, I'll just summarize it. This argument that yesterday was shared by Prakriti and Shiv, what they were unconsciously assuming was a completely elastic collision. Okay, where complete transfer of momentum takes place. So then what Ishan was suggesting cannot happen because the moving ball will come and it will transfer all of its momentum to the other ball, then the other ball will go off. So then there is no question of any residual velocity left in this ball for it to also move forward. But what
yeah,
Ishan was saying was, in reality, collisions are never completely elastic or completely inelastic. Okay, so what he
exactly.
was referring was a kind of inelastic collision. And yes, in reality, inelastic collisions are the ones that happen all the time in nature. And even though two objects are of the same mass, when they collide with one
Do you
another,
mean elastic happen or inelastic happen?
uh,
Inelastic.
Ishan, the doubt that Ishan got was because he did not believe that this is a completely elastic collision. So he said, what if it is an inelastic collision? Of course, he didn't use these words, but
Yeah, 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 yeah.
what it meant. What if this collision was not a 100% elastic collision? Then why can't the mass m1 be left with some velocity to move forward? In reality, in life, that happens all the time. Okay,
All right, all
so,
right.
so that is so that it I feel that it was a nice way in which, even if it was a bit messy to begin with, a nice way to move into the understanding of elastic and inelastic collisions, which is also an essential part of what we do in momentum, by understanding this situation. So now I hope it has become clear that when you give an argument to say that this situation is not possible, you are assuming that the collisions are 100% elastic. Then this it is not possible. But in real life, of course, it is possible because there is no such thing as a 100% elastic collision. Collisions are partly inelastic and partly
Partly elastic. Yeah.
elastic. So that is how it happens. We don't need to worry about that any more than that, but that's the way it is stated. So any questions or doubts anybody has, you can ask now. So that's all for today. I hope that finally lays to rest the entire question about how things happen. So we found out our way to elastic and inelastic collisions and the discussion of the same by the result of inquiring questions being asked by students. If you like this video, please press the like button. Do consider subscribing for the channel, and if you feel somebody will be benefited by this video, please forward it to them. Thank you.